Penguin Random House Audio presents The Attention Fix: How to Focus in a World That Wants to Distract You by Dr. Anders Hansen. Read for you by Dr. Anders Hansen and Nikolas Salmon.
Preface. In May of 2018, I attended the American Psychiatric Association annual meeting in New York, where 10,000 colleagues from around the world gather in one place to hear from world-leading brain scientists about their latest findings. When attending conferences like the APA, it's not always what's being said in the lectures that is the most interesting part. At least as exciting is getting a sense of the issues that interest and concern psychiatrists and researchers the most. In the spring of 2018, I heard many colleagues ask each other the same recurring question. What are we exposing ourselves to with digitalization? Are we conducting a gigantic experiment with ourselves and our children as guinea pigs? No one had a definitive answer, but everyone agreed that the changes we have seen in human behavior over the last 10 years, in terms of how we communicate with and compare ourselves to each other, are extremely far-reaching and might affect us on a deeper level than we think. Many suspected that the vast increase in the number of young people seeking help for mental health problems may be at least partly due to our swift embracing of a digital lifestyle. Even though my colleagues seem to have more questions than answers, we're not entirely clueless. Research into the effects of digitalization on the brain may be in its infancy, but our knowledge is growing by the day. After the APA conference, I realized that never in human history have we changed our behavior as rapidly as we have in the last few decades. And it's not just our digital habits that have changed. We're also experiencing a different form of stress than in the past. We're also sleeping less and being more sedentary. All of this means that the brain has ventured into uncharted territory. This book is about the consequences.
Chapter 1. The World That Shaped Us. Imagine 10,000 dots. Now imagine that each dot corresponds to one generation of humans since our species emerged in East Africa some 200,000 years ago. All the dots combined represent the history of humanity. How many of these generations lived in the world you and I know, with cars, electricity, running water and TV sets? 8 dots. How many lived in a world with computers, mobile phones and air travel? 3 dots. How many have never experienced anything but a world with smartphones, Facebook and the internet? 1 dot. This book is about the most advanced structure we know of in the universe, the seat of everything we have experienced, our feelings, memories and consciousness, our brain. This is an organ that in a strange way feels both alien and a little frightening to us, but at the same time is us. The brain has been molded over eons of time to fit the world in which it exists, a world radically different from the one you and I, who make up the last few dots, are familiar with. Evolution. The basis of life on Earth. You and I are the result of a process without meaning or purpose. Evolution is neither good nor evil, benevolent nor malevolent. It's an essential condition for life on Earth and the process through which we adapt to the world around us. But how does it work when evolution adapts all species to their environment? As an example, let's consider a group of bears in North America, venturing further and further north until they eventually reach Alaska, where they wander around in the Arctic cold. The bear's brown fur makes it difficult for them to camouflage themselves against the snow, so they are often spotted by the seals that are the only prey around. The bears get to the brink of starvation. In one of the female bear's egg cells, a random change, known as a mutation, occurs in a gene that affects the color of the bear's fur, making it white. The cub born with white fur has an easier time sneaking up on seals than the other bears. This makes it better at hunting, which in turn increases its chances of surviving and eventually having cubs of its own. These are also born with white fur and are therefore more likely to survive and have their own cubs, and so on. Gradually, the brown bears are outcompeted, and after a time, which might be tens or hundreds of thousands of years, many bears in Alaska have white fur, so white that we call them polar bears. Any hereditary trait that increases an organism's chances of survival and reproduction will become increasingly common over time. In this way, all plants and animals, including humans, have adapted to their environment. If gradually spreading the white fur color through a population of bears sounds like evolutionary grunt work, that's exactly what it is. It takes a long time, a really long time, for major changes to occur within a species. Instead of a polar bear, now let's imagine a human living on the savannah, say 100,000 years ago. We'll call her Anna. Anna finds a tree full of sweet, high-calorie fruits. She eats a fruit and walks away feeling satisfied and content. The next morning, she is hungry again and decides to go back for more. But by then, the fruit is gone. Someone else has picked it. In the world Anna inhabits, the empty tree can be a matter of life and death, as 15 to 20% of all people die of starvation. Now let's imagine another woman, Mary, living on the same savannah. Mary carries a mutation in a gene that affects how she experiences the taste of sugar. When she bites into one of the sweet fruits, her brain releases a particularly large amount of a molecule called dopamine, which plays a role in making us feel good and motivating us to do various things. You can hear more about dopamine later. As a result, she gets a violent urge to eat all the fruit on the tree. She doesn't settle for just one, but gobbles up as many as she can. After a while, she is full up and stumbles off. The next morning, Mary wakes up and wants something sweet again. But when she returns to the tree, someone has already picked the handful of fruit she left behind. Bad news, yes. But she ate so many the day before that she has built up a reserve. It's not hard to guess that Mary is the woman with the best chance of survival. The calories she doesn't use are stored in her body as abdominal fat, protecting her from starvation when times are tough. This means that Mary has a better chance of passing on her genes by having children. And because her calorie cravings are caused by a gene, although in reality a number of genes rather than a single gene contribute to cravings, the same trait is passed on to the next generation, who in turn will have a better chance of surviving and procreating. Gradually, more and more children are born with a strong craving for calories, and they all have a better chance of making it. Slowly but surely, over thousands of years, the craving for calories becomes an increasingly common trait among the population. But let's transplant Anna and Mary into the modern world of fast food restaurants. When Anna spots a McDonald's, she goes inside for a burger, leaving satisfied and not too full. When Mary walks into the McDonald's, however, she orders a burger with fries, Coca-Cola and ice cream, leaving the restaurant absolutely stuffed. The next morning, she wakes up hungry again and returns to find the restaurant as fully stocked as the day before. She orders the same meal as yesterday. After a few months, this gluttony has taken a toll on Mary's body. Not only has she put on quite a few excess pounds, she has also begun to develop type 2 diabetes, as her body is struggling to cope with her soaring blood sugar. Now, the roles are reversed. The hunger for calories that enabled Mary to survive on the savannah isn't an asset in today's world. Suddenly, the same biological mechanism that helped us survive for 99.9% of our time on Earth is doing more harm than good. This is not some hypothetical example, but exactly what has happened. We have brought the calorie craving that evolution built into us over.
Sample complete. Ready to continue?